throughout Earth's 4.5 billion-year history, it has changed from a fiery volcanic rock to a frozen lump of ice hurtling through space. While environmental factors, such as forest fires, El Niño and man-made emissions can impact the climate in the short term, in the very long term the planet's tectonic plates are the dominant force. Geologists now believe that in Earth's past, the movement of giant landmasses may have caused a dramatic shift in the planet's climate, resulting in the Earth plunging into two separate ice ages. The findings indicate huge tectonic events can kickstart massive shifts in the climate lasting millions of years. Evidence suggests that just before these two events, 80 million and 50 million years ago, there were huge collisions between tectonic plates at the equator. Coinciding with both of these global cold snaps, the levels of carbon dioxide in the atmosphere fell drastically. Now a team of geologists at the Massachusetts Institute of Technology believes the combination of the tectonic events, combined with weathering of rocks at the equator, sucked carbon dioxide out of the atmosphere and cooled the planet enough to bring on an ice age. Everybody agrees that on geological timescales over hundreds of millions of years, tectonics control the climate, but we didn't know how to connect this, explained Dr. Oliver Jagouts, an associate professor of Earth, Atmospheric and Planetary Sciences at MIT. I think we're the first ones to really link large-scale tectonic events to climate change. More than 180 million years ago, Earth's landmasses were divided into supercontinents. Fragments of one of these ancient supercontinents, called Gondwana, which eventually splintered to form Antarctica, South America, Africa, India and Australia, pushed northwards from the until it collided with the Eurasian supercontinent. By analyzing rock fragments in the ancient Himalaya mountain range, the team's previous work showed that Gondwana fragments were crushed into Eurasia. But around 90 million years ago, the African plate smashed into an oceanic plate at the equator, driving up a chain of volcanoes, just like the island chains in Southeast Asia or the Pacific Ocean today. As the African plate continued to drive its way underneath the oceanic plate, it lifted the edge of the plate even further so that by 80 million years ago, it had effectively flattened the volcanoes and exposed ocean rock. Just 30 million years later, India is thought to have merged with Eurasia in a second mammoth collision in which a different region of the oceanic plate was pushed up onto the continent. In both instances, the fresh rock was exposed to the atmosphere in equatorial regions where wind brings more rain. Due to the type of rock found in the oceanic plate, they absorbed carbon dioxide as they were weathered by the atmosphere. The MIT team believe that at both of these geological milestones, the exposed rocks acted like a sponge to suck carbon dioxide out of the atmosphere, robbing the Earth of its warming properties and beckoning in an ice age. Geologists say that the effect was so extreme because new rock was constantly churned up by the advancing tectonic plates. They add that a similar process can be seen taking place near the island of Java today, on a much smaller scale. What nature shows us is, if you put a lot of these rocks in the tropics, where it's hot, muggy, wet, and rains every day, and you also have the effect of removing the soil constantly by tectonics and thus exposing fresh rocks, then you have an excellent trigger for ice ages, explained Jagouts. But the question is whether that is a mechanism that works on the time scale that is relevant for us.